Good afternoon, everyone. Thanks for joining today's webinar. My name is Lumish. I'm from DJI Enterprise as the solution engineer based in Australia. So it's a pleasure to present our latest drone-based solution tailored for the electrical utility industry. So before we start, let's just have a quick look at what's coming up in the next hour. So for the first 10 minutes, I will kick things off by showing case our latest hardware and automation solutions designed specifically for the utility sector, including drones like the Matrix 400, and Zemius payloads, and our DJI Dock autonomous platform. So for the next 40 minutes, the team from the Unleash Live will take over demonstrating how AI and cloud analytics can turn inspection data into intelligent decisions, from fraud detection to reporting automation, all in real time. So and after that, we have approximately like 15 minutes. We will wrap up with a live Q&A session. So feel free to drop your questions in the chat box during anytime during the webinar. So we will try our best to address as many as we can at the end. So without further ado, let's just jump into the first session. The electrical utility sector is undergoing a major transformation. So with the increasing demand, aging infrastructure, and climate pressure, this industry is looking for smarter, more scalable ways to maintain and monitor assets. So key characteristics of this industry includes the first one, obviously, is the capital intensity. So massive investments are required for infrastructure development. Wide area coverage, power lines often span hundreds of kilometers across remote areas. Labor intensity, inspections are frequent, repetitive, and physically demanding. So all these challenges create a strong incentive to invest in drone-based automation and digitalization. And so let's brief understand what we are dealing with. So a typical power system includes, a generation, transmission, distribution, and end user consumption. So inspection demands focus mostly on the transmission and distribution stages, where infrastructure is exposed to weather, vegetation, and mechanical stress. So our goal is to help utility create digital replicas of these assets so they can inspect, monitor, and manage them proactively without relying solely on manual labor or costly helicopter missions. In practical terms, you may wonder what needs to be inspected. Firstly, obviously, is the infrastructure digital twin. So you need to build a 3D model for better planning and maintenance. And also vegetation management is quite, significant as well to identify, the tree encroachments before they cause outages. And also the next one, obviously, is the transmission line inspection, which, required to detect, faults, corrosion, and thermal anomalies. And after that, distribution line inspection also is quite important for the industry. You need to regular, to check the conductors, insulators, and hardware integrity. And last one is the substation inspection. The purpose of this inspection is to verify the health of complex structures and equipment. So our solutions address all of these needs with one integrated drone platform. So traditional inspection methods are no longer, sufficient. So usually there are several limitations that we are facing. So the first one is lack of digital information. So no scalable way to build asset models, and it's quite low efficiency and high risk. Manual inspections require, working at heights, near live feeders, or in remote areas, which is very hard to access to, and also slow response in remote regions. Emergencies often, involve long delays before teams arrive, and also high cost of the helicopters. Manned flights are expensive and weather dependent. So this is why we believe drone-based inspection is not just a supplement, it is the future core capability for utilities. So here is the architecture that DJI solution for electrical utilities. So we offer a comprehensive system tailored to utility industry. So you can see that we have the big platform called the M400 RTK, which is able to compatible with our H30 and also the L2, and you can just simply plug out different payloads according to your mission requirements. And also we have the small drones like the Matrix 4 serials, which is equipped with RGB camera, and also for the thermal version, it also have the capability to provide infrared images. It's quite compact and very easy to carry. And also for the payloads, we have something like the H30 serials, which have the nicing mode capability, and also we have the L2 ladder units. You can even use it in a very uh, dark light environment. And speaking of the software, so we have the FlyHub 2, which is the fleet management platform. And also we have the DT83, which is the thermal software help you to reconstruct the thermal model. And also we have the Terra Modify to help you to get the model, and you can just edit it according to your requirements. And besides of that, we also have the automatic platform is called the DJI Dock. Yeah. Yeah. Speaking of our latest product, Matrix 400. So let's just take a close look at the latest products. Here is some features I would like highlight to you. The first one obviously is the endurance, so which is up to 59 minutes flight time with payload, and also the speed is up to like 25 meters per second. And also it's equipped with a lidar unit on the top of the aircraft which is able to sense the obstacle along the power lines, and also it's quite robust with the IP55 rating for all weather operation. And for the payload flexibility, it is able to carry up to 6 kilograms and support 7 payloads simultaneously. And speaking of the Zenmuse H30, so you can see that when high resolution imagery is needed, so the H30 can help you in this aspect. So this one is equipped with the visual camera, which has up to 112 multiply times hybrid zooms, and also it's has the is able to provide the thermal image up to 1280 times 1024, and it is also have the capability to switch to the night scene modes, give you a very clear vision even in very low light environments. And also the laser rangefinder is up to like 1800 meters distance measurements. And besides of that, it also have a very handy features like the smart capture, electronic dehazing, and also the video foreground stabilization. And besides of that, it's also able to to operate from minus 20 Celsius to 50 Celsius. Yep, here is some footages that's captured by the H30. You can see the high resolution is quite impressive, and also you can see the thermal images captured by the our payloads. So this replace what used to require like climbing, binoculars or helicopters, and this all in just a single 5-minute flight. Yeah, the next one I would like to highlight is the M4 serials. So this is for lower voltage urban and regional networks scenarios. So you can see that the M4 series is quite compact and mobile, easy for the the field teams, and also it equipped with the the 3 times medium tele and also the thermal integration. And one more thing that I would like to mention here is foreground stabilization. It ensures the clarity even with the zoom, and also it has the enhanced obstacle avoidance to protect the drones near the poles and the wires. So you can see that this is a go-to solution for routine maintenance and rapid response in metropolis grids. So here is the thermal images that captured by the M40, and you can see that you can pinpoint, the old heating drawings, transformers, or arresters, helping, the operators to locate the equipment failure. And this gives, the field engineers the insight they need without ever, touching a pole. And now, we have seen how DJI drones platforms and autonomous systems enable efficient, high-quality data collection for utility inspections. And the next question is, how do we make sense of all the data quickly, accurately, and at a scale? So this is where Unleash Live comes in. So Unleash is a leading AI video analytics platform that turns drones footage and the live stream into actionable insights, helping utility operators detect faults, prioritize maintenance, and automate reporting workflows. To show us how that works in the real world, I would like to hand a presentation over to the Unleash team for the next session.
Hello everybody, my name's Hamid Fardoust. I lead the Australian business at Unleash Live. I've been helping shape the industrial automation and remote monitoring space using computer vision since 2018, and it's been a fascinating journey. The landscape has changed an unbelievable amount in that time, especially with the rise of drones, edge computing, and AI at scale. In this session, I want to share how we're working closely with partners like DJI and applying computer vision to help energy organizations get more out of their assets, whether it's by reducing inspection costs, improving safety, or unlocking data they previously couldn't see. So, as we look at the current landscape in energy, one thing is clear. Operational and maintenance costs are quietly becoming the sector's biggest liability. More than half of an asset's total life cycle cost is spent after it's been built, just keeping it running. What's more concerning is that when these projects are initially approved, the long-term costs are significantly underestimated. We're seeing actual O&M expenses coming in at 2 to 3 times higher than forecasted in business cases. That discrepancy has a real-world impact. It's not just a budget issue. It cuts directly into returns. On average, we're seeing a 20 to 21% shortfall in ROI compared to original plans. So if we break that down by segment, we see that in the power transmission and distribution space, say the US alone, is dealing with a staggering 180 million aging poles, and utilities often don't have good visibility into their precise condition. The result being rising costs tied to regulatory compliance, safety-driven replacements, and costs that many operators are struggling to keep up with. Wind is also facing its own headwinds. We're expecting around $40 billion in O&M spend over the next decade, with a huge chunk, almost something like 60%, attributed purely to downtime. Every hour a turbine isn't turning is money lost. And with solar, while scaling rapidly, presents its own set of challenges. As the installed base grows, expected to be something like 8 times larger by 2050, then manpower and time required for inspections becomes a bottleneck. Right now, it takes a 4-person team about an hour and a half per megawatt. Multiply that across utility scaled installations, and you've got an enormous resource burden. The big picture here is that the economics of energy assets are being redefined, not just by capital costs, but by how effectively we manage and maintain them over time. That's where smarter tools, automation, and better data comes into play. So to provide some context on who we are, Unleash Live is a software company that's been around since 2016. We specialize in enabling autonomous remote inspections using real-time video and imagery analytics powered by machine learning. That means helping organizations capture visual data from drones, fixed cameras, or mobile platforms, and automatically extract the insights they need to make decisions faster. With headquarters in Australia and active operations in the US, we work with more than 50 enterprise clients around the world. In the energy and infrastructure space here in Australia, that includes many of the leading names in the utility sector, organizations managing vast networks of poles and wires and critical assets. So whether it's improving safety, reducing downtime, or scaling inspections without scaling headcount, our platform is designed to help these teams act on visual data in real time. So here on the left, you can see the range of devices we work with. And as I mentioned before, whether it's fixed IP cameras, DJI enterprise drones, or your existing video management systems like Bosch or Milestone or Genetec, we're hardware agnostic. So that means we fit into your current setup without the need for new infrastructure. And so once that data is captured, it flows into our platform shown here in the middle, where it's processed in the cloud or at the edge or on premises, or even in hybrid environments. We apply computer vision machine learning to automate tasks like inspections, detection, and analysis. That includes our autopilot capability for drone flights, real-time defect detection, and scalable asset management. At this moment, we have some 60 plus AI models across energy, resources, and transport ready to be deployed at scale. On the right here, we connect these insights into your existing systems. So whether you're using tools like Power BI, Tableau, or platforms like SAP or Aviva, or even Safety Culture, we delivered that structured data and visual intelligence directly into the customer's workflow that they already have. The end result being faster decision making, less manual review, and ultimately a much more scalable way to manage inspections and operations. So drilling down a little bit further here, this slide speaks specifically to the drone automation aspect of our platform and how it connects data collection, AI analysis, and operational response into a single streamlined workflow. On the left, we start with automated data collection. For example, when inspecting wind turbines, we can optimize flight paths based on the specific turbine type, layout, and inspection profile. Crews can select from a range of mission templates, and live video can be streamed directly back to the control center, enabling decisions in real time, even while the drone is still in the air. In the middle, that captured data is run through our AI-based image analysis pipeline. We automatically detect faults, structural issues, or component degradation, and we can align those outputs with each customer's internal maintenance standards. So you're not just getting raw results, you're getting insights tailored to your operational thresholds. And finally, on the right, the action layer, if you like. This is where we translate insights into meaningful outcomes, like fleet-wide dashboards for prioritizing repairs, generating historical reports for trend analysis, or triggering work orders automatically through APIs. The goal here is to eliminate time spent manually reviewing footage, reduce unnecessary field trips, and help teams close the loop faster between observation and action. And so with that, I'll hand over Richard to provide a walkthrough of the platform.
Thank you, Hamid. My name's Richard. I'm a field solutions specialist here at Unleash Live. My role is typically myself out in the field with customers to familiarize them with the tools for different styles of inspections. Today we'll be focusing primarily on distribution use case. So how do we capture poles in the field effectively across multiple different stakeholders within the business? To do this, we'll be utilizing two tools. We organize these inside of Unleash as our Orb offering. These two tools are Unleash Live Cloud and AutoFly. So I will be jumping between these two components throughout this session. I will let you know which component we are utilizing at any given time. So to start off with, I will jump into our cloud platform just to show you what you can expect when you first log into Unleash Live. And what you'll see is this page here. So immediately on logging into Unleash Live, you will see our streaming page. Streaming is a core component. We leave this at the top because of its emergency response capabilities. So as you have pilots in the field, they're able to stream directly from their AutoFly controller into our platform. Moving through, we have a media drive where we store and manage all different kinds of data associated to inspections and maintenance. Our GIS tool, which we name Atlas, where we can apply different kinds of layers, such as KML layers of asset locations, shapefiles, GeoJSONs, or 2D models. Analysis page, this is where our reports are kept once we generate computer vision. Remote cockpit, this is our home for remote operations. As we will dive into AutoFly, you will see features that allow us to operate aircraft remotely from the cloud. We have jobs and tasks, which is a core pre-field component of large-scale network inspections. And then our AI App Store, which is a core component of who we are at Unleash Live. So today we will jump directly into the pre-field component of setting up an in-field inspection, which is our jobs and tasks panel. So any large-scale infrastructure will require multiple pilots to go out and collect data. We manage these collections through what we call a job. A job is primarily a group effort at collecting a set of data. So this can be something such as a pre-summer bushfire inspection. So we can create this new job as PSBI 2025. And this job may be broken down into individual tasks that we can assign to pilots in the field. So we want to populate our users. These can be pilots. I'll have myself and Hamid join the team. And with these users, I can now assign tasks to their user accounts. So by adding a task here, I can select layers. All of these layers are found in our Atlas. I choose feeder 3 to be inspected. And feeder 3 here, as you can see, is overlaid onto our base map. This is just a small subset of poles as a demonstration. However, you can bring in up to 500,000 to 1,000,000 assets using this tool, and we can break the inspections up accordingly. So I typically choose to draw my markers using the drawing tool as opposed to the polygon or box. So I can select these 4 markers, for instance, and I can add these to a task. Now, without having to break up the KML layer, I can add an additional task. I can draw this task in here. And I can add these second markers to a task. So I now have 2 tasks that are broken up. As I would be expanding out, I will know that all of these markers have been selected, therefore no poles have been missed. I can assign these markers to different pilots. So I can assign this one to Hamid. I can rename this to Corridor 1. I can assign this corridor to myself and rename Corridor 2. So I now have these 2 tasks assigned to 2 different pilots. I know that my whole layer has been populated with tasks, therefore I'm not missing any assets. I can finish this, and I have 2 ways of creating these missions. I can create manual tasks where a pilot goes out and manually flies these missions. We have a tool called Smart Inspect, which applies a form of automation to each asset, but it requires the pilot to fly between the assets. Or we can apply an automated task, which is the full corridor inspection. The reason why we would differentiate these is, say, a customer doesn't have the height and exact GPS location of their assets, we can create a manual task. But if all of this is provided through a geo-rectified LiDAR file or an RTK point of that asset, we can then go ahead and create these automated flight tasks. From these automated flight tasks, we can apply a mission profile and assign a speed of the collection. So I have now applied two tasks, to this job PSBI 2025. I can see the start points for the jobs and tasks and the assignees. If I need to see any more details of that task, I can select that and I can view the task in here. And I can also view these tasks in our mission viewer. So I now have corridor 1 and 2 generated. I can preview this mission, and I can also preview this mission in 3D. If we were to apply a LiDAR point cloud to here, we would be able to see the aircraft flying between LiDAR points, and we can edit this accordingly if any points are intercepted. So we can view this in real time, how it would behave in this environment. And I can now see that these tasks are ready and assigned to all pilots. I can jump into the AutoFly application to show you how these appear to the pilots. So to do that, I'll be utilizing our streaming tool. So I'll be streaming directly from AutoFly into our cloud account. Selecting stream here. Let me just start my stream. This will now come into view here. So great. So welcome to AutoFly. So AutoFly here is our version of DJI Pilot. It enables many of the features that DJI Pilot has. However, it has a full integration into our own cloud system, being Unleash Cloud. From here, we have access to all of our KML layers that we brought into Fusion Atlas. We can view these by tapping on the icons and zoom in, and I can populate these layers through our Atlas layer format here. So by selecting feeder 3 and turning those on, I can zoom right in on those and see the mission that has been assigned to me. Jumping back into the camera view, I can select C2 on the back of the GCS, and it'll open up the mission that is assigned to me. In this instant, it is corridor inspection 1. And as you can see here, as I select it, it is populating on here. And I can also view jobs as a whole. I have my PSBI, and I can also see Hamid's task here. It is saying someone else's task, and therefore I do not need to complete. I did also mention we had some other forms of automation, and these are what we call smart inspect profiles. If you are to fly a pole manually, we have the ability to apply a automated flight profile around that asset. So by selecting something like SI distribution simple, the pilot would just position the aircraft above the asset, tap start, and it will do a 5-point image of the pole. Because of the challenges of demoing these live, we have pre-recorded this inspection profile. So playing that now. So the pilot will open up that mission panel, select the mission, and hold to start. From here, the aircraft is completely automated. So it is flying to its first waypoint, which is that pole at the end. At any time, the pilot can pause that mission, stop that mission, and add any additional manual images to that mission profile. So once it finds its first waypoint, it will drop down to directly above the pole. Each mission is roughly 1 to 1.5 meters above the asset when it is taking images. And the beauty of this style of inspection is that we can ensure that it is very accurate and repeatable data that we bring back into the platform for computer vision at a later date. Next time we go out to conduct these inspections, this corridor mission is a pre-existing mission in our platform. Therefore, the next inspection profile will be conducted in the exact same way. And our ability to then overlay these images will give us a real advantage in continued development of our computer vision, and also a way of being able to review change over time from inspection to inspection. When it comes to data quality and data accuracy, there's no beating automation in this application. So as this mission comes to a close, typically the pilot will either bring this down automatically, or in the settings we can have a return to home feature. So this can be conducted through a drone in a box application. And we can then set up in our settings to automatically upload the files from the drone to the cloud platform without the need to eject the SD card from the aircraft. This is hugely advantageous, especially when you're working across many different assets or different teams. It enables us to make sure that the data that is collected in the field can be associated to the right asset, but also ensures that those files are not then lost through poor handling of the SD card itself. So jumping back in here, I will go back into my stream here. I'll demonstrate how easy it is to upload the files on completion of a mission. So once landing, the pilot will select the Unleash Live icon, select Media Sync, and simply select Sync All. Sync All will update or sync all of the data that has been saved on the SD card. And the next time that they were to be out in the field and conduct more inspections, it's not going to double handle that imagery. It is only going to bring in the relevant data for the day's work. We have the ability to delete files after sync. So if you are an organization that has data security concerns utilizing third-party drone service providers, this is a way that we can ensure that all files are uploaded upon landing and then automatically deleted after sync. Now that the media has been uploaded from the device in the field, we unlock the capabilities of Media Drive. So all data that's uploaded from AutoFly will be associated to a folder based on the job or mission that's associated to that asset. So by selecting this folder here, I can apply computer vision by selecting a model to run in this folder. So I can select Analyze and apply our Powerline inventory model. I have just completed an analysis of this feeder. So by selecting this folder here, I can select my images, and view the high resolution image viewer here where I can zoom in, do my inspections, and annotate these components individually. So computer vision allows us to really streamline the workflow of a post-field inspector. So getting a good understanding of what components are on the pole or what severities have been found post the field inspection without human eyes on. So we can see all of the components highlighted here, and we can also add any manual annotations to this as we please. So we can select add, we can use our click tool. This is a segment anything model where we can highlight over individual components within this model to add any additional annotations or tags. All of these additional annotations and tags can be utilized to retrain this model for an even more accurate detection next time. Users can then apply a severity to these items and any other comments that they would like to use for the exported report. And on completion of analyzing this particular image, we can select reviewed. So now that we know that these are reviewed, the lines team will not have to come back to this image. They know that that one has been completed and reviewed. Now that all of the, I'll just show you a few of the other images. So these are all 5 images of this asset. We'll have a top down and 4 in each corner. Once those images have been completed, we can select the folder or the complete folder and view the report that has been built for that using that AI model. So we have the folder name, the file type, and obviously the annotation that has been applied to that asset. From here, we can export via PDF, CSV, or CocoJSON, however our client typically likes that data set. Sometimes they are exporting into other platforms, which is why we apply a CSV here. Typically, a PDF report is what is most utilized. So thank you. That's a very quick overview of our platform from the pre-field component of building out our jobs and tasks right through to our media drive where we are managing the field inspection data that has come through and pushing those outputs out as reports. I hope you learnt a little bit about how we apply computer vision and automation through our tools and software. I'm looking forward to answering any of your questions. Feel free to shoot them across in the Q&A.
Okay, thank you, Richard. So let's just move to the next session, which is the Q&A session. So if you have any questions, just feel free to drop into the chat box. And yeah, and we see a lot of questions here. I think the first question is for the Unleash Live. So what kind of accuracy and fault detection rates are you achieving compared to traditional ground or helicopter-based inspections?
Thanks, Lumen. Thanks, Lumen. I'll take that. So typically speaking, we see somewhere in the region of 90 to 98% detection accuracy for critical defects. Obviously, this is a training, retraining process that we go through. And conservative estimates are somewhere in the region of, say, 20 to 30% higher than manual helicopter surveys. This is generally due to image quality, really, so distance, speed, blurriness, etc. And then there's the high repeatability, if you like, of autofly. So this ability to gather consistent, repeatable, high quality images, and subsequently and providing this higher fault detection. So Unleash solve the problem of reducing the heavy lifting of computer vision by really taking on the automation component so that you're getting high quality images through that automation, in addition to the gains, the productivity gains of being able to capture more poles in any one sitting, so to speak.
Thank you, Hamid. And next one is, how are you addressing data management challenges, particularly with the large volumes of imagery and video collected during inspections?
I think I can answer that one. So I guess the tools that we've been showcasing today are already a massive step forward for organizations with their management of the data. So in the past, we would see large volumes of data just being brought in as one raw, big lump sum of imagery. So the way that we have done this through AutoFly is being able to break each asset up into a particular folder. So there is the automation on the side of foldering those imagery from the field. And then as we bring it into the platform, we then apply use cases such as filtering on the edge, being able to integrate that with external tools like GIS and EAMs to be able to aggregate those images to specific assets geospatially, but not just geospatially, but folded for a later date as an asset passport, as you will. So we can now view this data going forward, making sure that it is perfectly overlaid, and then applying that computer vision as well. So you have multi-levels and multi-layers of understanding your asset asset performance and managing all of that data in different ways that we feel fit.
Yeah, okay.
I see
Thank you.
another question that I probably want to answer as well. So there might have been a bit of confusion on, are we manually doing these annotations on the poles, or are we applying computer vision to do the detection on the asset or components and the faults? So we do the training of the AI. The AI that you saw on that demonstration there was completely automated. So that has learnt over time from the images that we collect, and it continues to learn over time. So there was no manual addition to that data set. Thank you, Lumen.
Yeah, okay. Thank you, Richard. So, got another question. So, what are the key considerations for utility that wants to scale from a pilot drone program to full network-wide automation?
What are the key considerations? So there's I think for the future of drones and automation, I think standardized workflows is a big consideration. So making sure that the image is captured repeatedly and accurately across your whole entire fleet, whether it's a new drone pilot or a very experienced drone pilot, these are very important. This is a very important step for the future of computer vision. Um, as we move more and more towards automation, I think regulatory readiness is another component of this, and being able to work with the right partners to ensure that you are in a place where you can legally go and operate these requirements. And we have some amazing regulatory people who we can put you in touch with. And then the change management side of things as well. So moving from one tool to a single workflow tool is quite a challenge. And then again, there's the data integration. So being able to make sure that that data that is being fed into something like Unleash Live is then utilized into an SAP or a Maximo, and streamlining that back into your backend. So there's a lot of automation that goes on behind the scenes of on top of the stuff that we've shown you today. And I think that's really where we spend a lot of our time, is helping you get through all of these. So we're not just here to provide you the software, but also help you with the full onboarding, the scaling of your operations, and bringing the process to you beyond just the inspection, but also integrating you into a very familiar workflow for the future to come.
Okay, thank you, Richard. And next one is, how does Unleash Live's AI model training adapt to different asset types, regions, or environmental conditions? For instance, vegetation, coastal, corrosion, bushfire risk zones.
I might take that one. So there's a couple of ways to kind of approach this one. So as Richard mentioned, there's the dedicated Smart Inspect profiles, which optimize the image capture for specific asset types. There's the custom model tuning, so AI models retrained with customer-specific imagery, so the unique pole type or the conductor hardware. And then there's the dynamic model selection, so selecting specifically tuned models adjusted for the local environmental factors such as lighting, location, asset condition, and so forth. And then finally, there's what we do with regards to benchmarking. So AI apps are tested, they're trained, retrained, they're tuned to work across various conditions, so including like rain, snow, brightness, and so forth.
Thank you, Hamid. And next one is how do you see the role of drones evolving over the next 2 to 3 years for utilities beyond just inspections?
I can answer that one. It's evolving very quickly. So drones now, and you've seen the DJI tools. We're now able to do so much more with them. And 2 years ago, I couldn't even imagine what we could do with them now. So in terms of utility inspections, I think there's going to be a lot more autonomous patrolling. So for early fault and vegetation risk assessment, I think that's going to be a huge feature of what we're going to see with drones as the regulation evolves. I think emergency response and situational awareness is another key component of this. In Australia, in Sydney, we've just had a weather bomb that's affected many people along the electrical grid. So being able to distribute drones at scale to get eyes on the situation and understand where they can apply fixes will massively change how quickly we can adapt and fix our infrastructure after emergency events. And then finally, having digital twins and 3D models of substations, lines, and corridors will play a, a big role in being able to simulate stress scenarios. So being able to kind of understand what may happen prior to an event. So I think drones shifting away from this reactive tool to more of a proactive asset in many instances is not just linear assets, but for all assets across many different verticals. I think it's going to be a very, very exciting space in the next 2 years.
Thank you, Richard. And another one is does the software recognize the components of the post or as users we mark and add all nodes?
I think I covered that one. Yeah, so we have both available. So AI obviously comes at a small cost. There is a processing fee that is applied to processing different computer vision models. But we have a perfectly capable annotation tool that can be rolled out at the early stages as you are to develop your model within your organizations. So being a modular platform, we can enable an organization not just with this full workflow, but also with AutoFlyer on its own to help you with your inspection and bring data back in, right through to maybe you just need an annotation tool, or you may need the full workflow, which allows you to then utilize computer vision to do that automated component of fault detection and component detection on your assets.
Okay, thank you. Um, I can see a lot of questions here, but considering the time, so I think we can only answer like two more questions. So the next one is what was the drone used for this exercise, and does any other type could achieve this level of detail and automation?
So for this exercise, we utilized the M4T. We obviously, being an AI company, we love to have the best hardware to be used in the field. But typically, we like to work with DJI enterprise devices. So having RTK is a very handy feature when getting very accurate data from the field. So any device that is a DJI Enterprise device, we can integrate. You can install AutoFly on that device. You're more than welcome to reach out to us. I can walk you through the installation of that and how to apply it in the field. But yeah, DJI, best hardware on the market at this point in time.
Thank you, Richard. So I think the last one will be, uh, is there a way for the AI to automatically detect defects without a manual review? Also, my organization uses Drone Deployer. How does Unleash Live replace, work with, or enhance our current platform?
Sorry, Lumen, could you repeat that? I'm just trying to have a look in the questions here.
So, is there a way for the AI to automatically detect defects without a manual review? Our Also, my organization uses Drone Deployer. How does Unleash Live replace, work with, or enhance our current platform?
Certainly. Yes, so there is, through training, we can have fully autonomous review of the assets, but we do like to keep a human in the loop just to continuously train as we push forward to the future. 90% is great, but obviously we all want 100%, and during this time there is that manual review process. I think Drone Deploy is a fantastic tool for certain situations. We have worked with Drone Deploy within some organizations where we applied different styles of workflows. I think Drone Deploy has a great tool for 3D mapping and 3D modeling. We work with them as a tool that people can utilize for the file storage. But then when it comes to the pre-planning and distributing the flights to multiple users, I think there is a differentiation there. So both great tools. How we integrate with those is very different according to each organization. So understanding your use of each of those tools will help us kind of integrate in a better way.
Okay, thank you, Richard. So, yeah, so I see a lot of still have a lot of questions here, but I think due to the time limitation, we can't answer all the questions one by one. But if you would like to learn more about the DJI or the Unleash Lab, just feel free to reach out to us. And yeah, thank you guys. Thank you for attending today's webinar. Yep, have a good day. Yep, see you guys.
Thanks, everyone.
Thank you. Bye bye.